Let's look at the global warming debate from a different angle. Mercury is the closest planet to the Sun. It should be the hottest planet, but it's not. Mercury's average surface temperature is about 330 degrees Fahrenheit, but Venus, which is further away, is almost 900 degrees. Earth is cooler than Mercury, but it should be a lot cooler than it is. Why is that? The short answer is, they have different atmospheres. Mercury has a very thin atmosphere, there's practically nothing there. So the side of the planet that's facing the Sun gets really hot, but as soon as it turns away from the light, it cools off quickly. There's nothing to trap the heat. But Venus has a thick atmosphere, so thick, you can't even see the planet's surface from space. That's a fantastic heat trap. Heat can get in, but it can't get out so easily. So it builds up, hence the average 900 degrees. But wait, what does it mean to trap heat? Why can the heat get in but not out? Well, the heat that's getting trapped is really just infrared light. It's what you see when you put on night vision goggles. It's a form of light that our eyes can't see, and when infrared light hits something, it heats up. When you sit close to a fire, that's infrared light heating your hands and face.
So something that's warm is going to look bright in the infrared, and something that's cold looks dark. Ice cream. Blow dryer.
Earth and Venus both have gases called greenhouse gases. The light our eyes can see, visible light, can get through a greenhouse gas just fine, but infrared light is blocked for the most part. So, if your planet's atmosphere has a lot of greenhouse gases, light from the Sun, which is mostly visible light, can get in, but infrared light can't get out. That infrared light will bounce right back down to the surface and heat it up further. This is normally a good thing. Greenhouse gases keep the Earth warm enough for human life, and they distribute the heat around so that it doesn't get too cold too fast at night. But too much of a good thing can be a bad thing. A long time ago, Venus had oceans just like the Earth. Real oceans with water. Venus no longer has those oceans. They were burned off by the heat trapped by the greenhouse gases in the atmosphere.
Liquid oceans on the surface. That kind of temperature only boils off that water into steam.
The main gas there is called carbon dioxide. It makes up 96.5% of Venus's atmosphere. You may have heard of carbon dioxide, also known as CO2. It's the gas that we talk about in the climate change debate on Earth. It's the gas that coal and natural gas power plants release, the gas that cars release, and so on. Altogether, humans put out 26 billion tons of CO2 each year, and that's a number that's growing. We know CO2 is a greenhouse gas because we can test it in a laboratory here on Earth. This was first done in 1861, when a scientist tried a whole bunch of gases to see which ones would stop infrared light. CO2 was one of the ones that did. CO2 isn't the strongest greenhouse gas. The strongest is actually water vapor. Methane is also a stronger greenhouse gas than CO2, but there isn't as much of it. And all of these greenhouse gases make up a very small percentage of the Earth's atmosphere. Water's about 1% and CO2 even less. But that's enough to make a big difference. It's enough to make Earth warm enough to live on. So my question is this. We know what greenhouse gases do. We can see that in a laboratory. We know what a planet without them looks like. We know what a planet with too much of them looks like. We know that they trap infrared light because of experiments in the lab. How could climate change not be happening? If we're putting into the atmosphere billions of tons of a gas that we know traps infrared light, how could that not be warming the Earth? That's all for now, folks. Thanks for watching.